Hello friends, today we are going to see Dikshitra's algorithm, which is a part of data structures and algorithms concepts. So this Dikshitra's algorithms, it is used to find out the shortest path which exists amongst a graph. So from node A to every other node, there is a shortest path, and this path is found by the Dikshitra's algorithm. The idea of this algorithm, it was being conceived by its Sir Dikshitra in 1956, and later in 1959 this research it was accepted. There are multiple variations of Dikshitra's algorithm, but the main variation remains that we start from the first node, maybe a node A or maybe a node 1, and we start finding the shortest path to every other node from node A or from node 1. This algorithm it is very helpful for the routing protocols of networking. It is also used to find out the shortest path, which is used by various maps to find out the road amongst two cities or two places. Also, it is used in open shortest path first method. So, today we will see one example of Dijkstra's algorithm. This Dikshitra's algorithm it is executed in multiple iterations. So let us see the example graph. As you can see on the left side in figure 1, we have multiple nodes given. So in iteration 1, we have to give a two pairs of the values where the first value it is about the cost to reach that particular node, and second value it will be about the helping node. For example, now since we are starting with node A, so the distance is 0 and none other node has helped us to reach to A, so the second value is none. Now we move to every other node, so we can see about node B. In this pair, we have the first value as an infinity, as the algorithm is yet to begin and we don't know the exact cost which is required to travel from A to B. Also, we are unaware that which helping node is useful to reach node B. So we have given infinity and none. As you can see for the node C also, since we are unaware of the cost required to travel from A to C, so we have given infinity, and also we are unaware that which is our helping node, so we have given none. So as of now, apart from the starting vertex A, every other node is being given with the value pair value cost and helping node, which is infinity and none. Let us move to the next iteration. Now we have started executing the algorithm, A being our initial node or the starting node. So now, since it is our current vertex, so I have given a emphasis on the node A, by highlighting it. So now we have to see that how we can go from A to the nodes which are immediate to A. That is, there exists a direct connection between the other nodes and A. So what we found out that A and B they are directly connected and the cost of age it is 7. So near to B I have written 7 comma E. Likewise for F the cost to reach F is 9, and for this A node is going to help us. So the pair value becomes 9 comma A. Again the same thing, we are using node A to reach to E. So the cost of the age is 40. Then the pair value becomes 14 comma A. In the next iteration, we have to see that how we can take help of the other nodes such as B, F and E. So we have to check that is there a connection between these three nodes and the other nodes. Also, we have to check for the minimum value. So we found out that from the values which are required to reach E, F and B are 14, 9 and 7. Amongst these three values, value 7 being the minimum, so the next helping node becomes B. So now using B, we have to see that is it possible to find out the minimum cost of reaching the next node. So now we have to take help of B and try to reach out the other nodes such as C, D, E and F. If there is a choice whether to go for the previous value or the newly found out value, then we have to see that which value is minimum. Let us go to the next iteration. The next iteration tells us that if we prefer going from node F to node E, the cost of reaching E it becomes 11. Earlier, when we tried to reach from A to E, the cost was 14. But if we go from A to E via node F, then the cost is 11. 9 plus 2 gives us 11. So near to E, I have written 11 comma F. Going ahead, again the same thing we found out that instead of going from B to C, if we prefer going from F to C, then the node C can be reached in minimum cost. Cost of going from A to F is 9 and from F to C it is 6. 9 plus 6 gives us 15, and this value is definitely lesser as compared to cost of going from A to B and B to C, which is 22. So from 15 and 22, 15 is a smaller value. So we have selected F to reach C and the cost is 15. So the pair value becomes 15 and F. Likewise, we go to the next iteration and we found out that now we have to reach the node D, which is yet to be discovered. So we will now find out the value of reaching D in the similar way. Then we found out the value comes out to be 20. So for that, what we have done, we have used E. The cost of reaching to E, it is 11, and for that the helping node is F. So we have used E to reach D. Now 11 plus 9 gives us 20. So 20 and E becomes the pair value to reach to D. Again, let me remind you that we have to see for the shortest path to reach a particular node. So now we will try with another nodes. So we found out that using node C, we can reach to D. So the pair value for C is 15, F. In this 15, if we add the cost of age CD, which is 4, so the resulting is 19. So 19 is the cost to reach to node D, and thus the pair value becomes 19 and C. In this way, we have completed the entire Dijkstra's algorithm, and near to each of the node there is a pair value given which tells us that what is the cost to reach to that particular node, and also it is going to tell us that which helping node or which route we have to follow. In this way, in today's video, we have seen that Dikshitra's algorithm, it is used to find out the shortest path which exists amongst the multiple nodes. So thank you for attending this session, and thank you so much.